In our last few videos, we looked at some methods for solving quadratic equations. And remember, a quadratic equation is any equation that has an x squared term in it as our highest term. And we saw that if there is no bx term, no x term, we're going to isolate this x squared part, just x squared, and then take the plus or minus square root of both sides. And that's going to be by far our easiest way of solving those. Then we saw that if there is a bx term, we want to get it into standard form, in other words, equal to 0, and we want to keep the ax squared term positive because it just makes our work moving forward easier. And then, just to keep making our work easier, we're going to divide out, completely cancel out any common numbers. But we're only going to do that if it does not create fractions. That number has to be common to every single term without creating a fraction. Then we're going to factor out, and you'll see why in a minute, why I use a different word here, out any common x's. We cannot divide those. We have to keep them. So we factor them out and then keep them. And then we try to factor. And we saw in our last video how to factor if my a was equal to 1. In this video, we're going to look at how do we factor if that coefficient of the x squared is not equal to 1. And this factoring is a little bit more complicated. And we're going to learn two different methods. We're going to learn what's called the guess and check method. And we're also going to learn what I call the AC method. You may use either method. Some students like one method, some students like the other. You may use either of these two methods, but you have to be able to factor quadratics where the coefficient is not equal to 1. We're going to be doing a lot of things moving forward for the rest of the semester where we are doing a lot of factoring. So it's very important that you master it at this step. Before we start trying to factor, we're going to practice actually multiplying and see our pattern, see how we come up with a quadratic that has a coefficient not equal to 1. So I'm going to go ahead and have you multiply these. Foil it out, combine like terms, and then let's do a different one here. So go ahead and foil both of those out, combine like terms, and get what that quadratic is equal to. Pause the video and then restart it when you're ready. All right, let's do this first one, and we're going to use that FOIL method, first, outer, inner, last. So 4x times x is 4x squared. 4x times negative 7 is negative 28x. 3 times x is 3x. And 3 times negative 7 is minus 21. And then we combine our middle terms, our x terms, and we see that we get a quadratic. Now notice here, I have a coefficient of 4. I cannot just say what two numbers multiply to give me negative 21 and add to give me negative 25. In the first place, there aren't any two numbers that do that. And in the second place, notice that multiplying by this 4 changes the process. So we're going to have to do more work on these. You cannot just say what numbers multiply to give me this and add to give me this because of the 4 here. Let's go ahead and try this one. We get 6x squared plus 22x minus 3x minus 11. Combine like terms. And we get 6x squared plus 19x minus 11. And again, we have a coefficient here. We cannot factor it back by saying what two numbers multiply to give this and add to give this, because this 2 affects those terms. So we're going to have to use a different process because of the 6 here and the 4 here. All right, let's go back and see what that process is. And we're going to use what's called the guess and check method first. So let's say that we have an equation that looks like this. And our instructions will say solve. And we will have an equation. It is quadratic because it has the x squared. It does have a bx term. So I want to get this equal to 0, keeping the x squared positive. You go ahead and do that. And I see I have 4x squared. The 2x and the 30 come over, so they have a negative 2x, a negative 30 equals 0. And now I'm going to try to factor this. I cannot just factor thinking negative, what numbers multiply to give me negative 30, add to give me negative 2, because of the 4. So I want to look through at each of my numbers and think, are they divisible by the same number? And in this case, I see that they are. Notice that I have here that I can divide every single one of these terms by 2. So I divide out that 2 and it is gone. And I have 2x squared minus x minus 15 equals 0. And unfortunately, I still have the 2. I do not want to divide by 2 and create a fraction 1/2 or 15 halves. I do not want to do that. So we're going to have to use either the guess and check method or the AC method. Let's try the guess and check method first. Remember when we were multiplying, this 4x came from the 4 here and the 1 here. So we know that when we are multiplying here, that whatever numbers I have here and here have to multiply to give me 2. In this case, the only thing that multiplies to give me 2 is 1 and 2. So I can put an x here and a 2x here. That's the only way I can get 2x squared. Then I think about the 15, the negative 15. The only way I can get that negative 15 is this number and this number multiply to give me negative 15. But those two numbers do not add to give me negative 1 because of this 2 here. So the easiest way to do this is to guess different ways that I can multiply using the x and the 2x and get negative 15. So I think of different ways I can multiply to get negative 15. Negative 15 and positive 1, or positive 1 and negative 15. Or I could have positive 3 and negative 5, or I could have negative 5 and positive 3, or I could have the signs changed on each of these. For instance, I could have positive 15 and negative 1, or negative 1 and positive 15. But in each case, the first part is the same. We already know that we have to have the x and the 2x. So I have a lot of different things that could possibly work to give me the 2x squared and the negative 15. So what's going to be important here is which one gives me the minus x in the middle. So I'm going to guess, and these are all of my possible guesses. So when I say guess, I mean kind of an educated guess, not just anything, but all of the ways that I could actually get the 2x squared and the negative 15. And obviously we have a lot of different ones here. We have a lot of different things that could multiply to give me the 2x squared and the negative 15. As you practice this, you're going to get better at figuring out which ones are more likely to work without having to check every single one. But I'm going to go ahead and check every single one of these just so you can see how this would work. So when I say check, I don't have to multiply the x and the 2x because I know that's going to give me 2x squared. I don't have to multiply the negative 15 and the 1 because I know that's going to give me negative 15 in every single case. That's how I chose the numbers I have. So what I'm checking are the outer and the inner. I'm checking x times 1, negative 15 times 2x. And I see, nope, that one doesn't work. So I can try the next one. But notice if I did the next one, that I'm going to get the same answer, except just the sign is changed. So I really didn't need to do that one. Then I flip-flopped here, and I see that I can do my outer and my inner. That one didn't work, so I know that one's not going to work. It would have just given me positive 13x. So then we can try this next one. And I see that's equal to x, and I see I'm getting close. Notice I have the same number, a coefficient of 1, but instead of having a minus, I have a plus. So that means if I flip-flop my signs here, that I'm going to have my 2 outer terms times my 2 inner terms gives me negative x, and this is the one that works. I don't even have to try those. So when I go back over here to write my factors, I have x minus 3 times 2x plus 5 equals 0. Notice that I did all my guess and check over here, not in the middle of the problem, because that just makes a mess. It's easier to do it to the side, do your checks, then come back into the problem. And notice I still have equals 0. It's still an equation. So now I can set each factor equal to 0 and solve for x. You go ahead and finish this problem out and then check back. All right, so we add 3 to both sides. Here we bring the 5 over. We divide by 2. And we see that we get x equals 3 and x equals negative 5/2. Whenever I have a factor, these are called my factors. This is a factor and this is a factor. They're the things that I multiply together to get this polynomial. So whenever I have a factor with a coefficient other than 1 in it, I know I'm going to end up with a fractional answer. Let's go ahead and do another one. I'm going to give you one here, and I want you to try using the guess and check method to solve this equation. So we have solved 3x squared minus 14x minus 5 equals 0. We have a bx term, so we want to try to factor. We have a coefficient of 3 here, so we try to think of two numbers that multiply to give me 3 are going to go at the beginning, here and here. Two numbers that multiply to give me negative 5 are going to go here and here. And then I have to do the guess and check to figure out which middle term will work. So I want you to try to do this on your own. Over here to the side, just write out all the different possible ones. Or you can just start, and then when you get to the correct one, stop. Write it out on the left here, solve the equation. Pause the video, try that, and start the video again when you're done. All right, the only way I can get 3x squared is 3x and x. So I'm thinking of numbers that multiply to give me negative 5. I'm going to have 1 and negative 5, or negative 1 and 5, and I can flip-flop those, and I can have 5 and negative 1, or negative 5 and 1. So I'm just going to start with the 1, the first one, and see what I get. And I'm checking the middle, the outer, and the inner, multiplying this one and this one. And I get negative 15x plus x. Well, I guess the very first one, I guessed it correctly. If I had started with some of these others, like for instance, I tried 3x minus 5x plus 1, then I would have seen that 3x minus 5x doesn't work, and so on. But since I guessed the correct one the very first try, I can just go ahead and put it back over here. Set each of those equal to 0. And then solve each one for x. And I have my two solutions. Okay. I told you that there's two methods. The method we've just looked at is called the guess and check method. And again, these are educated guesses. We know that these two numbers have to multiply to give me this, and we know that these two numbers have to multiply to give me this, and then we just check the different ones to see which one gives me the correct middle term. The method that we're going to look at next is called the AC method. And again, you can use either method. I'm going to show you both of them, but you may use either one of these methods. So let's go back and look at this same equation that we had before. 4x squared equals 2x plus 30. And we have a bx term, so we get it in standard form, keeping our x squared positive. We divide out any common numbers, and in this case we divided out a 2. And so now we have our equation to solve. So what the AC method says is to multiply the first and the last term, the A and the C, the two numbers there. So I'm going to multiply 2 times negative 15 and get negative 30. And then what I'm going to do is find factors of negative 30, of that AC, that multiply, or excuse me, that add to get the B term. So find factors of the AC term that add to get the B term, in this case, negative 1. So we're looking for two numbers that multiply to give me negative 30 and add to give me negative 1. And what this does is it takes into So you try to figure out what those two numbers are. And hopefully you figured out that they are -6 and 5, because -6 times 5 is -30, -6 plus 5 equals -1. And then we're going to rewrite the equation. Remember, back when we were doing our multiplication to come up with our quadratic polynomials, every time we ended up with two middle terms here, the outer and the inner term, that we combined to give our new middle term. When we do the AC method, what we're doing is kind of going backwards here. We're going to split this apart into the two separate terms, and we see that they're going to be -6x and 5x. The 2x squared is going to stay the same, and the -15 is going to same, and the equals 0 will stay the same. And what we're doing is we're breaking this minus x into those two separate middle terms, the outer and the inner terms. And now what we're going to do is called factor by grouping. And what factoring by grouping does is it says, okay, let's look at the first two terms. Let's look at those first two terms and divide out anything that's common to both of those. So we look at 2x squared, we look at -6x, and we see that the largest possible common thing is 2x. If we divide out a 2x from 2x squared, we get x. If we divide out a 2x from -6x, we get -3. Then we look at our second two terms, 5x and -15, and we want to divide out the largest possible thing that we can here, and in this case that's +5. And when we divide a 5 out of 5x, we get x. When we divide a 5 out of -15, we get -3. And this is still equal to 0. All right, now watch what happens here. Notice that this and this are exactly the same. If they are not exactly the same, then I've done the factoring by grouping incorrectly, or factoring by grouping doesn't work. But because this and this are exactly the same, I can factor that out. I can factor out the x minus 3. And when I factor the x minus 3 out from here, I'm left with 2x. When I factor the x minus 3 out from here, I'm left with +5. And I see that I have a completely factored problem, and I can set each of those equal to 0 and solve for x. And of course, we got the same answer that we did using factoring by guess and check. All right, I'm going to have you practice that method, practice the AC method with our other equation that we used. And this one's already in standard form with the x squared positive. So we look for any numbers to divide out. We look for any common variables to divide out, factor out. Then we use the AC method. So I want you to look back at your notes, what we just did, and see if you can use that method to solve this quadratic equation. Pause the video, do the work, and then check back. All right, so we're using the AC method, so we multiply 3 times -5. So we're looking for two numbers that multiply to give me -15 and add to get -14. And we see that those two numbers are -15 and +1. So negative 15 and 1 are our two coefficients of x, so we rewrite this. And if you put plus 1x minus 15x minus 5, that's perfectly fine. It doesn't matter the order that you have, because remember when we said the factors can be in either order? It just makes the work a little different, but you end up with the same exact factors. So we broke the negative 14x into its two pieces, negative 15x plus x. And then we do our factoring by grouping. So we look at our first two terms first, and we can factor out a 3x. And then we look at our second two terms here. And notice we don't have anything common here. We have just an x and a minus 5. So that means that if we're factoring something out here to write what we're putting here, we're actually taking out a 1. We're not really factoring anything out, but that's an understood 1. And then we're just left with our x minus 5. So when we factor out the x minus 5, when we divide it back out front, we're left with the 3x and the plus 1. And we have this completely factored. So I can set each factor equal to 0 and solve for x. And again, we get the same answer. Some students really like the AC method. Some students really like guess and check. But just be careful when you're doing one process or the other that you're not combining the two things. If you're going to do this AC method where you're saying numbers that multiply and add, don't forget to do the factoring by grouping to get your final answer. All right, we're going to look at one more example here. Notice that when we did our steps here, notice I slipped one in on you here. I slipped in this factor out any common x's. So let's look at what happens when we can do that. Let's say that we have an equation that looks like this. And we're going to solve. Let's say we have 5x squared equals 45x. And I need to solve this. So my first step is to think, do I have a bx term? And yes, I do. I have an x right here, so I have a bx term. I cannot do that, isolate this x squared and take the plus or minus square root. That will not work. So my next step is to get this equal to 0, keeping x squared positive. So I bring the negative 45x across, and I have equals 0. Then my next step is to divide out, completely divide out any common numbers. I can divide out a 5. So I have x squared minus 9x, and 0 divided by 5 is just 0. Now's the time to think about that next step. Factor out any common variables. If I have an x in every single term, I can factor out that x. I cannot divide by x and cancel it. I have to factor it out. That means I have to keep that x. So when I factor x out of x squared, I'm left with an x. When I factor an x out of minus 9x, I'm left with minus 9. And notice I do actually have two factors here. This x is one of my factors, and then x minus 9 is my other factor. Because remember, a factor is what you multiply together to get the original polynomial. So this x is one of my factors. I can't just divide it out and lose it. Then my next step is to set each factor, and here my factor is x. I just set it equal to 0, and I get x equals 0. So x equals 0 is one of my solutions. And then I set x minus 9 equal to 0, and I get x equals 9 is my other solution. So if I plugged a 0 in here and here, obviously that's true. 0 equals 0. If I plugged a 9 in here and here, when I did the math, I would get a true statement. So watch out for that step. If every one of your terms has an x in it, we know that we're going to factor out that x, and one of my solutions is going to be x equals 0. In our next video, we're going to look at what do I do if the polynomial will not factor. We're going to learn a method to solve any quadratic equation even if it will not factor.